Hello everyone, welcome guys. I am and as we are seeing thermodynamics, in that thermodynamics we have covered first law of thermodynamics and zeroth law of thermodynamics. There are 4 lectures which previously I have uploaded on video. You can go through those videos and then you will get the link of the lecture which I am going to conduct right now. In that we have seen introduction of second law of thermodynamics, which deals with enthalpy and spontaneity of a reaction. Enthalpy means what? It is a form of heat either which is given out or accepted by the system when it is carrying out any physical or chemical change in itself. Very important, it is either physical or chemical change. Now, physical change means what? Either ice can get converted to liquid, means there is change in state. Solid gas, solid will get converted to liquid, liquid will get converted to gas. These conversions include physical changes. Those are said to be like physical states or physical changes. Next, we are having chemical changes. In chemical changes, we can have few examples like where when we add HCl in water or when we add KNO3 in water, what happens is there is change in its temperature, and that study is under thermodynamics. And we have seen the first law of thermodynamics has some drawbacks. So to overcome those drawbacks, second law of thermodynamics was introduced, where second law of thermodynamics tells us that the spontaneity of the reaction is unidirectional. Means what? Water always flows from top to bottom, means it moves from less random state to more random state. Means it is moving from higher level to lower level, where randomness of that water goes on increasing. Or there is another thing that the heat always moves from hot end to cold end. Means what? The randomness, that metal is getting hot, molecules are vibrating more, that means randomness has increased. Cold end has less random atoms. Hot end, heat moves from hot end to cold end. So this unidirectional flow of heat or current is explained with the help of thermodynamics, and in thermodynamics it is second law of thermodynamics. In the second law of thermodynamics, second law deals with enthalpy and entropy. Entropy is said to be as randomness and enthalpy is termed as heat. Now here we are knowing heat of fusion or heat of vaporization. These all terms are familiar to us. Heat of fusion means what? When solid is getting converted to liquid, the heat is absorbed. That transfer of heat or acceptance of heat is known as what? Enthalpy of fusion. Next is enthalpy of solidification, means what? When liquid will get converted to solid. Now when liquid is getting converted to solid, heat is given out. That's why when we add liquid in refrigerator absorbs heat from that liquid, cools the temperature of that liquid and converts it into solid. Means any liquid to get converted to solid, it has to lose its energy. When the energy is lost, more random state goes to less random state, liquid will get converted to solid. But the natural general tendency is what? Solid will always get converted to liquid naturally. You don't need to carry out any different process for that. Or naturally liquid will get converted to gas. So in this way, there is a spontaneous flow where gases are in more random state. Gaseous molecules are in more random state. That's why you can't pinpoint the gaseous molecules. Whereas solids are rigid and the randomness of atoms is not much as compared to gases. Similarly, enthalpy of fusion means what? It is a natural process. Solid will get converted to liquid. Next, when we try to solidify it, liquid will get converted to solid. Next, enthalpy of vaporization means what? Liquid is getting converted to gas at room temperature. Evaporation and vaporization, these are two different concepts. Evaporation means what? Boiling point is attained, means you have boiled the water at 100 degrees Celsius. At 100 degrees Celsius, water is getting converted to liquid, that is known as what? Vaporization. After boiling point, when the liquid molecules are getting converted to gaseous state, it is known as vaporization. And evaporation means what? At room temperature, naturally, liquid is getting converted to gas, that is known as what? That process is known as evaporation. So, vaporization means what? Temperature after 100 degrees Celsius or heat required for liquid molecules to get converted to gases after 100 degrees Celsius. So, that is known as what? Enthalpy of vaporization. We know enthalpy of sublimation. And that I can show these representations based on the energy profile diagram. Now this is what energy of solid, this is what energy of liquid, and this is energy of gas. Now enthalpy of fusion means what? Solid is getting converted to liquid. Enthalpy of vaporization means what? Liquid is getting converted to gas. Here, enthalpy of sublimation means what? Solid directly gets converted to gaseous state. And when it is going into gaseous state, the energy absorbed, amount of energy absorbed is represented, and that energy is known as enthalpy of sublimation. Now, this enthalpy is calculated for 1 mole of that solid. So, according to definition, you can go through the textbook. I am just explaining the concept. In textbooks, you will get a proper definition where in definition they have said that the amount of energy required to convert 1 mole of solid into its gaseous state. What I am saying is the amount of energy required to convert 1 mole of solid into its gaseous state is known as enthalpy of sublimation. So, in enthalpy of vaporization also what? The amount of energy required to convert 1 mole of liquid into its gaseous state is known as enthalpy of vaporization. Similarly, enthalpy of fusion means what? The amount of energy required to convert 1 mole of solid into its liquid state. So, these enthalpies have approximately the same arrangement of statements. If you learn one statement, it will be easy for you to frame the definitions of the other enthalpies also. So, you can do the relative study, means by learning one definition, it will be easy for you to remember the other definitions. What you have to do is, you have to just change 1 or 2 words from the previous definition. So, when you try to study in this way, you will be able to write the definitions which are asked in the exams. Majority of the times, these definitions are asked in boards for 1 mark each and in colleges also. So, be very careful with these definitions. There are actually 11 enthalpies, definition of 11 enthalpies that you are going to understand. I am just going to explain the concept, what is lying between them. The definition which you have to learn, it is up to you. So, these were the concepts which we have seen for enthalpies of vaporization, fusion and sublimation. Next, we are having enthalpy of ionization. Enthalpy of ionization, again, amount of energy required to ionize 1 mole of solid or gas, means 1 mole of a compound in its standard state. Standard state, I will explain you one example for enthalpy of ionization. Here I am having 1 mole of sodium solid sodium. It is in its standard state. So, to ionize that 1 mole of solid into its ions, we need some amount of energy. That required energy is known as enthalpy of ionization. Why enthalpy of ionization? Because we have converted ions from its solid state or its standard state. So this is what enthalpy of ionization. Here there are again 2 conditions. Sodium, to convert solid sodium into its ionic state, we need to supply energy. There is one more case where chlorine will easily accept an electron and give you a negatively charged ion, where chlorine is in gaseous state, which is its standard state. Now, to convert these chlorine atoms, this chlorine molecule, into its ions. Okay, to convert this gaseous state into its chlorine ions, that enthalpy, that heat is known as what? Enthalpy of ionization. There are two conditions. Solid getting converted to its ions, there can be positive ions and negative ions both. So that energy is known as what? Enthalpy of ionization. Next we are having enthalpy of atomization. Enthalpy of atomization means what? The sodium which is in solid state. Here we are going to have sodium atom only. Sodium has 11 electrons. Here also we are having 11 electrons. But that sodium atom is in its gaseous state. That is known as what? Enthalpy of atomization. Here also I will give you one more example. Chlorine gas, same. Here I will have two chlorine atoms which are in gaseous state. Okay. Here again we are using 1 mole of each. 1 mole of sodium, solid sodium, 1 mole of chlorine gas, and we are trying to make atoms of chlorine from that gas. So while carrying out this process, the amount of heat used is known as what? Enthalpy of atomization. Enthalpy of atomization म्हणजे कळलं का? समजा क्लोरीन गॅस असेल, त्या क्लोरीन गॅसचे मी काय केले? ॲटम्स तयार केले. मग ॲटम तयार करताना जेवढी काही हीट एकतर ॲब्सॉर्ब केली असेल किंवा दिली गेली असेल, so that heat either absorbed or given out is known as what? Enthalpy of atomization. Next, enthalpy of solution. Enthalpy of solution means what? When we are trying to make solutions, different kinds of solutions. आता ही जी enthalpy आहे solutions ची, I will give you one example. When we are using CuSO4 to dissolve in water, the heat is given out. First, I am having a container. In this container, I am having only water. We can't say this as a solution. Next, I add CuSO4 crystals in this water. Then what will happen? I will get the solution of CuSO4. So, while we are making solution of CuSO4, either heat is given out or absorbed. So that heat is known as what? Enthalpy of solution. Okay, I will give you one more example. Then generally we are making HCl solution. In our labs we are using NaOH, 2 normal NaOH solution, 2 normal HCl solution, 2 normal NH4Cl solution. So while making those solutions, either there is exchange of heat between system and surrounding. Okay, so that exchange of heat is known as what? Enthalpy of solution. So here it is an exothermic process. Exothermic process means what? Where heat is given out to the surrounding. And endothermic process means what? The heat is absorbed from the surrounding. Endothermic means what? Heat is absorbed from the surrounding. So these are the two different parts for exothermic and endothermic reactions. Now this enthalpy of solution. आता CuSO4, then I will add CuSO4 in water. It will show increase in temperature of that solution by 1 degree Celsius, 2 degree Celsius or 3 degree Celsius. Max up to max 4 degree Celsius. Okay, but when I will make solution of HCl, in that case I will see large increase in temperature up to 6 degree Celsius or 8 degree Celsius or 9 degree Celsius. The temperature, as you add drops of HCl, the temperature will go on increasing. So, how does this change in temperature is possible while we are making solution? What does this lead to change in temperature? का बरं वाढतं temperature? की ह्याच्या आपण सोल्युशन केलं, CuSO4 चं सोल्युशन केलं तर टेम्परेचर वेगळा वाढला, कमी जास्त झालं. HCl जर केलं तर भरपूर प्रमाणात वाढलं. जर मी NaOH पाण्यामध्ये डिसॉल्व केलं तर अजूनच टेम्परेचर वाढतं. तर त्याचे टेम्परेचर व्हेरिएशन आहे की हे टेम्परेचर कशामुळे व्हॅरी होतात. सो देयर आर 3 कंडिशन्स विच लीड टू द चेंज इन इट्स एंथॅल्पी. CuSO4 चं 4 डिग्री का वाढलं आणि HCl चं जे आहे ते 9 किंवा 10 डिग्री सेल्सियसनी का वाढलं, याचं कारण म्हणजे इट इज डिपेंडिंग अपॉन द इंटरॅक्शन्स बिटवीन सोल्यूट पार्टिकल्स, सॉल्व्हंट पार्टिकल्स अँड सोल्यूट पार्टिकल्स. उदाहरण सांगतो. सोल्यूट पार्टिकल्स म्हणजे समजा मी HCl आणि HCl घेतला, सोल्यूट इंटरॅक्शन HCl आणि HCl. Means what? I am having HCl solution. या HCl मॉलिक्युल्स मध्ये जर इंटरॅक्शन स्ट्रॉंग असेल, या HCl च्या मॉलिक्युल्स मध्ये इंटरॅक्शन स्ट्रॉंग आहे आणि मी ते पाण्यामध्ये घातलं, तर ते मी जर त्यांना पाण्यामध्ये घातलं तर ते एकमेकांपासून लांब होणार नाही. का बरं? कारण यांच्यातच एवढं इंटरॅक्शन आहे की ते पाण्यामध्ये घातल्यावर डिझॉल्व्ह होणार नाही, म्हणजे हीट बाहेर निघण्याचा संबंध नाही. हा एक मुद्दा आहे. वेअर सोल्यूट सोल्यूट मधलंच इंटरॅक्शन स्ट्रॉंग आहे. दुसरं म्हणजे सॉल्व्हंट इंटरॅक्शन म्हणजे काय? जर सॉल्व्हंटच्या मॉलिक्युल्स मध्येच स्ट्रॉंग इंटरॅक्शन असेल तर सोल्यूट त्याच्यामध्ये डिझॉल्व्ह होऊ शकत नाही आणि हीटही बाहेर पडत नाही. हीट कधी बाहेर पडते? जेव्हा त्यांच्यातला बॉन्ड ब्रेक होतो किंवा बॉन्ड फॉर्म होतो. इन these two conditions only there is exchange of heat between system and surrounding. So in this way HCl चा एक भाग आहे. त्यानंतर सोल्यूट इंटरॅक्शन पाहिलं, सॉल्व्हंट इंटरॅक्शन पाहिलं. दुसरा एक भाग आहे सोल्यूट सॉल्व्हंट इंटरॅक्शन. सोल्यूट सॉल्व्हंट इंटरॅक्शन म्हणजे काय? हा झाला सॉल्व्हंट वॉटर आणि हा HCl झाला सोल्यूट. मग सोल्यूट आणि सॉल्व्हंट मध्ये जेवढं स्ट्रॉंग इंटरॅक्शन असेल तेवढी स्टॅबिलिटी जास्त आणि तेवढी हीट जास्त बाहेर पडते. म्हणून जेव्हा आपण HCl पाण्यामध्ये घालतो त्यावेळेस आपल्याला H3O+ आयन्स आणि Cl- आयन्स आपल्याला मिळतात. बरोबर? मग हे जे आयन्स आहेत हे एवढे स्टेबल आहेत की एक्सेस अमाऊंट ऑफ हीट बाहेर दिली जाते आणि टेम्परेचर व्हॅरी होते. इंटरॅक्शन जर कमी असेल तर हीट कमी बाहेर पडणार, इंटरॅक्शन जर स्ट्रॉंग असेल तर हीट जास्त बाहेर पडणार. अशा पद्धतीने ही जी हीट ऑफ सोल्युशन आहे, दॅट हीट ऑफ सोल्युशन इज डिपेंडिंग अपॉन द 3 टाइप्स ऑफ इंटरॅक्शन: सोल्यूट इंटरॅक्शन, सॉल्व्हंट इंटरॅक्शन अँड सोल्यूट इंटरॅक्शन. ओके, नेक्स्ट वी आर हॅविंग एन्थॅल्पी ऑफ डायल्यूशन. आता एन्थॅल्पी ऑफ डायल्यूशन आणि एन्थॅल्पी ऑफ सोल्युशन याच्यामध्ये खूप फरक आहे. डायल्यूट आपण सोल्युशन करतो, म्हणजे जर मी 2 नॉर्मल सोल्युशन केल्यानंतर जर मी त्याला डायल्यूट करायला गेलो त्यावेळी जी हीट बाहेर पडणार त्याला मी म्हणणार एन्थॅल्पी ऑफ डायल्यूशन. मीन्स व्हॉट? इफ इनिशियली आय एम मेकिंग 2 नॉर्मल सोल्युशन. फॉर मेकिंग 2 नॉर्मल सोल्युशन आय एम युजिंग वॉटर and concentrated HCl. Okay, we are using concentrated solute and solvent to make solution. In dilution we dilute the solution. इथे solvent वेगळा, इथे solute वेगळा, मिक्स केलं, सोल्युशन झालं. आता त्या सोल्युशन मध्ये आपण पाणी घातलं, पाणी घालताना जी काही हीट बाहेर पडली दॅट इज नोन एज व्हॉट? एन्थॅल्पी ऑफ सोल्युशन और एन्थॅल्पी ऑफ डायल्यूशन. सॉरी, एन्थॅल्पी ऑफ डायल्यूशन म्हणजे काय? कळलं का? मी सोल्युशन जे घेतलंय त्या सोल्युशनला मी डायल्यूट करत गेलो, हीट घेतली गेली किंवा बाहेर दिली गेली, दॅट इज नोन एज व्हॉट? एन्थॅल्पी ऑफ डायल्यूशन.